React is a programming model for user interfaces. ReactJS is for building user interfaces for web applications. React Native is for building UI on Android and iOS. ReactVR is for building user interfaces in virtual reality. React Native was originally developed to make it easier to maintain parity between the web, iOS, and Android teams at Facebook. If I build an application for the web with ReactJS, I can rewrite that application for React Native on iOS or Android and reuse some of my code from that web application. It's not a one-click level of portability between platforms, but it helps share user interface components between the different platforms. ReactVR brings React development to virtual reality. Andrew Imm is a ReactVR developer at Facebook, and he joins the show to discuss how ReactVR works. We talk about the support for VR in the browser, WebGL, WebVR, and ThreeJs. And we also explore some of the key React components that you might use to build an interface in ReactVR. And we wrap up the show by exploring VR more broadly, how consumers use VR today, and how they might use it in the future. We've done so many other shows about React, including many shows about the basics of how React works. You can download the Software Engineering Daily app for iOS or Android and hear all of our old episodes and easily discover new topics that might interest you. There's a recommendation system, and with 600 episodes, that's quite useful because it's kind of hard to find the episodes that will appeal to you. If you don't like this episode, you can easily find something more interesting by looking at the recommendations in the app. The mobile app is the first project to come out of the Software Engineering Daily open source ecosystem, and there are more projects on the way. We're working on a new web app for Software Engineering Daily. We're working on the recommendation system, the mobile apps, and we would love if you were interested to get involved to come by. You can come to github.com/softwareengineeringdaily and contribute. You can also go to the Slack channel, or you can just send me an email, jeff@softwareengineeringdaily.com, if you're interested in contributing but you don't know how. And with that, let's get on with this episode. DigitalOcean Spaces gives you simple object storage with a beautiful user interface. You need an easy way to host objects like images and videos. Your users need to upload objects like PDFs and music files. DigitalOcean built Spaces because every application uses object storage. Spaces simplifies object storage with automatic scalability, reliability, and low cost. But the user interface takes it over the top. I've built a lot of web applications, and I always use some kind of object storage. The other object storage dashboards that I've used are confusing, they're painful, and they feel like they were built 10 years ago. DigitalOcean Spaces is modern object storage with a modern UI that you will love to use. It's like the UI for Dropbox, but with the pricing of a raw object storage. I almost want to use it like a consumer product. To try DigitalOcean Spaces, go to do.co/sedaily and get 2 months of Spaces plus a $10 credit to use on any other DigitalOcean products. You get this credit even if you have been with DigitalOcean for a while. You can spend it on Spaces or you can spend it on anything else in DigitalOcean, and it's a nice added bonus just for trying out Spaces. The pricing is simple. $5 per month, which includes 250 gigabytes of storage and 1 terabyte of outbound bandwidth. There are no costs per request, and additional storage is priced at the lowest rate available, just a cent per gigabyte transferred and 2 cents per gigabyte stored. There won't be any surprises on your bill. DigitalOcean simplifies the cloud. They look for every opportunity to remove friction from a developer's experience. I'm already using DigitalOcean Spaces to host music and video files for a product that I'm building, and I love it. I think you will too. Check it out at do.co/sedaily and get that free $10 credit in addition to 2 months of Spaces for free. That's do.co/sedaily. Andrew Imm is an engineer at Facebook working on ReactVR. Andrew, welcome to Software Engineering Daily.
Thanks. I'm glad to be on the show today.
Today we're talking about ReactVR, and let's start with the React programming model. I've done shows about React on the web, on devices with React Native. The React programming model is being applied to all kinds of surfaces. I think I talked to Netflix about how it works on televisions. Why is React useful for building so many different kinds of UIs?
Sure. Well, I've been lucky enough to be involved in developing React applications for a very long time. I mean, before we were even using it in production at Facebook. So I've been able to watch it evolve from a very web-oriented system to something that now works across all these different platforms in 2D, 3D, even hardware. And I think what makes React work so well, not only across all of these platforms, but also feel so good to developers, is the way that it's structured as an abstraction. When you write React code, you are describing it in a way that gets transformed into this intermediate format, that virtual DOM, as people like to call it. This tree in memory is representing your application's state at any time. And that allows React as a system to send individual UI diffs to whatever the rendering layer is. But you don't have to think about that as a React developer. And so what makes it great for moving across platforms is you can swap out that final piece, the rendering engine, to something entirely different and get pixels on a screen that are coming from iOS's UI view or the DOM, Android views, even rendering to the GPU with the same style of JavaScript code on that front end. Mm-hmm. And this is also why I think that React is desirable to modern developers, is because they can build an application without even having to know how that rendering layer works. I honestly don't know that much about Cocoa or the UI layer on iOS, but I've been able to build iOS applications using React Native.
Right, and so we did a really good show about this topic of, it was basically, we did a show about the interface layer between, well, the interface between your React code and whatever the underlying substrate is. It was with someone from Leland Richardson, I think, from Airbnb. And, we really got into the details of just why this is what you get out of your React code and the interactions in your React code and how that changes over time. It really is just emitting a change set of that UI, and that's getting interpreted by whatever the underlying layer is. So it's almost like this. It's almost like the Java sort of write once, run anywhere thing. But I think the React way of putting it is like write once,
learn once, write everywhere. Yeah,
learn once, write everywhere. Because there are, and the reason that for the difference is because there are unavoidable differences between, for example, a VR experience and the experience on a phone. In those kinds of differences, you're going to need to resolve how you want things to appear in your code. There's just no getting around it, but that effort is perhaps minimized.
Yeah, so I think you're never going to have a scenario where you have a phone application that you can just drop into VR and have everything look exactly as intended. There's just differences when you move from platform to platform. That's also why you see React Native applications sharing, say, 90% of their code across iOS and Android. So that last 10% is accounting for the core differences in the underlying UI layers, things that people expect with look and feel. But there's also challenges moving into VR with input systems and things of that nature. That's been one of the fun challenges of building ReactVR as a library, is trying to expose as much 3D input as possible, which is a totally new concept in React, without having to dramatically change the event system or the way that people write components.
Well, let's set the stage for what we're discussing with this kind of what's different in in VR, and then we'll get into how React makes for a world that we can start to play with these sort of new things. You mentioned this three-dimensional world that we're starting to play with. We have sensors that are picking up different things in that three-dimensional world. We have sensors that we're holding, and we have the sensors that are in the VR headset that we might put on. what kinds of sensors do we need in VR? And as somebody that's working in this space, what do you need to know about the sensors?
Sure. So I'm going to talk about the headsets first because that's, I guess, the most prominent aspect of VR. And headsets fall into two different categories based on what types of sensors they have in them. You have what we call 3 degrees of freedom and 6 degrees of freedom. The former is sort of your cardboard Daydream Samsung Gear VR headset, where you can look around, but you can't move through that world. And this lets you get a sense of a full 360-degree view around yourself, but you can't sort of duck and dodge and walk around a world at room scale, as they call it. The 6 degrees of freedom headsets have some sort of internal or external tracking that allows you to also know when the user is shifting to the left, to the right, and jumping up and down. So these are things like Oculus Rift or the HTC Vive. Microsoft's coming out with a bunch of mixed reality headsets. And so already we have sort of two classes of ways that people are simultaneously consuming and updating the point of view in that world. And so as a VR system, you need to be able to not only render to this headset based on some precision of a camera in the world, but also be able to adapt to both scenarios and create an experience that is going to be immersive for both the positional tracked headsets and just the orientation tracked ones. And what's interesting about ReactVR is not everyone has a headset. This is still very new technology. And one thing we've tried to do is take your existing phone or your existing laptop and give you an opportunity to experience a VR world, even if you don't own a headset yet. So for instance, if you pull it up on your phone, we use the orientation sensors in there the same way that a cardboard or a Daydream headset works. And we can use that as a magic window into that VR world. So by moving the phone around your head, you can start to see different areas and start to interact with it. So we try to span this full gamut of experiential models. And it's one of the interesting challenges is trying to make them almost invisible to the developer. So they can write that application once and assume that the broadest audience can enjoy it.
Okay, so to be clear, if in the experience where I put let's say I take my smartphone and I put it into a little headset, just kind of a dumb headset, and I'm using let's say I'm using the sensors on my smartphone, is that possible? Or how would that contrast with the experience of like an Oculus Rift where you have a fully fledged VR device? Because it seems like there's a difference in the sensors that are in those two device setups.
Sure. So with the phone scenario, that's how Samsung Gear VR works. That's how Google Daydream works. All these cardboard devices that you see, they're just taking positional and rotation sensors in the phone and translating that into some sense of where you are looking in the world. And then they use that to render from that viewport. And so as long as you're seated, you can still feel fairly immersed in a world, especially if you're doing something like viewing 360 photography or 360 videos, these captures of the real world or virtual worlds that surround you on all sides. You can look up, down, left, right. Now, the difference from that to positional is if you start to have near field or far field objects, 3D objects in that world as well, you start to notice a disconnect. If you shift to the left slightly, you won't experience that parallax effect, that slight shift that you'd see in real life. But with positionally tracked headsets, we can add that extra set of information. So the Rift is able to not only understand where you're looking, but also where you are in the room. And so if I have two panels in front of each other, the first one's blocking the second, I can shift over to my left and then start to see the back one peek out from behind.
And I get that as a React developer, I don't want to have to deal with knowing the differences in the sensors in the underlying platform. But as the developer of ReactVR, to what degree do you need to know about the sensors as the person who's developing the stack that developers are working with?
We need to be thinking about just about every single potential input scenario. But we do want to be hiding it from the developer, at least to the extent that they don't need to be worrying about it. So our team is accounting for everything from someone using a traditional desktop PC with a mouse clicking around a world to drag and see different views, to someone using a phone or a tablet where they can rotate that and look around, to people with a wide range of headsets, because we have people who are doing these things on phones with, say, Daydream, which supports WebVR and Chrome in the latest versions, for people who are going to be using full-fledged desktop headsets like Rift, and Firefox 55 is coming out later this month, and that's going to have full support for these WebVR APIs too. So you're going to be able to talk to a positionally tracked headset on your desktop PC using your web browser, which is an exciting thought. And then we're working with people who are developing these specs to understand not only the systems that we have to support today, but also what does the future look like. So for instance, there are people at Google exploring combining that information with AR cameras to expand this same setup of WebVR to work with augmented reality. So we have to start thinking forward to that as well, and make sure that any systems we're building are going to adapt cleanly to that setup in the future.
Where do the ReactVR apps run? Are we talking about a device-specific experience, like a native app type of experience? Are we talking about in the browser? Give people who are unfamiliar with this territory a bit of an understanding of the runtime.
Sure. So I think my ideal answer would be that one day it'll be any VR platform. But right now we're limited in what we've built out so far. So ReactVR is a lot like React Native. In fact, it is built on React Native. But it's like React Native in that you can add new platforms simply by implementing that last piece of the runtime, the thing that translates raw adds and subtracts of the scene into actual pixels on a screen. And so far, the most prominent version of ReactVR that you'll find out there is the one that we've released as open source. And this is targeting a web browser and those WebVR APIs that I talked about just earlier. So you can build a JavaScript application entirely in ReactVR, deploy it to your website, and then people, regardless of whether it's a 2D display, a phone, a VR display, are going to be able to consume that world that you've built. And the reason that we targeted the web first for our initial launch is because that's going to allow developers to get started with very little supporting tech. You just need JavaScript and a web browser, essentially. And it allows them to reach the widest audiences as well. Because if we limited ourselves just to VR headsets, developers are missing out on a huge group of people who want to consume compelling 360 content. So by making this available on the web and making it work with your standard 2D browsers and your mobile phone browsers, we're trying to create the most compelling development experience for people who want to get started in VR. Now, internally at Oculus, we actually have a different version of ReactVR that we use to power a lot of our first-party apps. My colleague Mike Armstrong gave a talk about this at the React Europe conference. It's very specific to our mobile tech stack, which is why it's not public now. But it has allowed our teams to move incredibly fast because they get to use web development techniques. They get to use the standard React tools that they know and are using on their web platforms as well. And we get to leverage a bunch of prior knowledge. It even got John Carmack to tweet about how effective ReactVR was making teams, which was a nice boost for us as a team.
You have a software project that you want to build. Everybody does. I love building products, but I know more about how software fits together than how to actually write the code itself. I don't spend a lot of time writing code, but I do like to build software. That's why I use TopTow. TopTow is the best place to find reasonably priced, extremely talented software engineers to build your projects from scratch. You can get a pair of Apple AirPods when you use toptow.com/sedaily to work with an engineer for at least 20 hours. And I recommend it. I think it's a great way to build your projects if you don't have time to build them yourself. There's a misconception that engineers have to build all of their own projects just because they're capable of doing that. It's not true. TopTow has only the top 3% of developers. They turn away 97% of the developers that apply to work on the TopTow platform, and that's how you get a matching process that's unlike anything else I have seen in the freelancer marketplace. And I've tried a lot of different freelancing platforms. TopTow has such high-quality engineers, and they listen through the design specifications that you have. They handpick the perfect developer for your project, and this has saved me countless hours in my development process. There's really nothing that compares to TopTow that I have seen. So you can get a free pair of Apple AirPods when you try TopTow at toptow.com/sedaily. Find an engineer that's going to help you build your side project and get your MVP off the ground. As long as you do at least 20 hours, you get those free Apple AirPods. And if you've already got a company that you're working on, you can also use TopTow to scale your team and get everything done faster and raise the bar for your engineering, or get through that blocker that's preventing your company from getting to the next level. So check out toptow.com/sedaily and find an engineer who will help your project succeed. Okay, and dive a little deeper into the stack that we're working with here. So it's built on React Native. What does that mean? If you want to build a VR, I think people know listening and kind of get a feel for what React Native is at this point, or if you don't know what React Native is, there's a lot of other episodes that we've done on it, but what does it mean to build a VR system on top of React Native?
Sure. So I know that in your session with Leland, you talked a bit about bridges and how React Native uses a bridge to communicate from a JavaScript context where your React code is running to some native implementation that is your UI layer. And so in VR, we're just re-implementing that last piece, which is rather than turning it into an iOS UI view, we're putting vertices into your GPU buffers and rendering 3D shapes to the screen. So the challenge there is we need to convert these view text image type primitives into their 3D counterparts. And let's just talk about the web stack, since that's the one that's out there and that's the one that people can play with today. So in the browser, everything's going to be JavaScript. So not only do you have a JavaScript context running your React application, but your quote unquote native runtime is also JavaScript because that's the language that we're speaking there. And so we've set this up where your React context is running separately in a web worker. And we use asynchronous message passing to implement that bridge to allow it to talk back to the main thread, the rendering thread in that runtime environment. So our runtime then takes messages from React, those add and remove and change operations that it spits out, and is able to turn that into things like text rendering with our own libraries. We're able to do a lot of the 3D model handling and positioning through leveraging ThreeJs, which is a fantastic open source library for talking to WebGL and rendering 3D objects in the web browser. Now, at first, this may seem like a bit of overkill. You're saying, why do you have a separate web worker to run your JavaScript if the whole thing is JavaScript and you can just execute it all in the same space? Well, it's actually very critical to the performance of ReactVR. So React Native was really effective because even if your JavaScript code was written inefficiently or something got hung up on the JS thread, the user could still interface with the native main rendering thread at that full 60 FPS. So even if you're blocked on loading the content of your scroll view, you can still scroll up and down. They're going to get that nice iOS momentum scrolling. And so it feels native to them. And this is very important to us in VR as well, because React is only updating the state of your world when something actually changes. Let's say I'm adding trees to a forest. I only need to make operations when one of those grows. I'm not constantly running React at 60 or 90 frames a second. So even if that React code in the web worker gets hung up on some costly operation, the user in the main thread is still going to be able to look around at the full frame rate. And that's absolutely critical for being in VR. If you want to create an immersive experience, I can't get the rendering all choppy or lagging. It needs to move as I move my head. And so being able to separate our React code out into that web worker is what lets us divide up these two different goals and really create the best VR experience entirely contained within a web browser.
You know what I think is going to be tough about the VR to mainstream issue is that the penalty for having a low performance or anything but a high performance VR experience is so high because people get sick. And the problem is the way that our devices are built today is that they're built to deprecate or I don't know what the wording is, but obsolescence. And the penalty for if people start falling in love with VR and then they're doing it on a mid-budget device, and when they buy that device, like the VR experience is good enough, and then over time it degrades, then they're going to start to be like, oh god, I'm getting sick from this VR experience and it's terrible. In building ReactVR, are you thinking ahead for those circumstances where like, oh geez, we need to really take device obsolescence seriously?
I'll be honest, this is the first that I've really given deep thought about it, but I think that the ability to limit limit the experience with just by running in the browser, almost as an experiential sandbox. You're going to, I think that it's very rare that you're going to have a scenario where someone builds something a couple of years from now that is just so immersive that running it on an older device takes something that used to look really good and starts to degrade it. Browsers are going to continue updating, and the APIs that they expose to us are going to keep updating. So if ReactVR is going to be more empowered to create more immersive experiences, I think that's going to be less about the underlying hardware changing and new generations of tech supporting things better, and actually more about us developing stronger open standards, and then the browser teams in turn implementing those in code. So this is one of the reasons that I'm really supportive of this WebVR effort that I've mentioned so far on the show. WebVR is a open W3C spec that's being developed by a lot of the browser vendors out there to allow the web browser to talk to a VR headset. And this is critical because if I wanted to leverage JavaScript to do all of the things that, say, an Oculus SDK does behind the scenes, whether that is rendering two different camera points of view and then warping those appropriately for the lenses, doing things that Oculus does like asynchronous time warp and space warp that allow you to get around potentially lagging frame rates. If I had to do all that in JavaScript, there wouldn't be time to run an application. JavaScript's great, browsers are powerful. I'm amazed with what we can do with them today, but there is a practical limitation. And so being able to talk to the low-level SDKs and being able to rely on that native code to handle the complexities of VR is what makes these VR experiences immersive, I think, for the long run. If you compare a VR experience on a Google Pixel phone, and you use Chrome supporting WebVR, and it talks to the Daydream subsystem, and it does all of these transforms and everything in a way that you can get really fast rendering. You take that and you compare it to, say, the Cardboard SDK, where it's doing all of these transforms on the JavaScript thread. It's night and day at the two experiences. Being able to rely on these browser APIs and being able to have some tighter access to this native hardware is what lets us build these really great experiences in VR, especially on mobile devices.
Interesting. Okay, so WebGL, how does that fit into this conversation? Is WebGL another one of these open standards that works together with WebVR?
Absolutely. So at some point in time, we have to go from these React tags and their abstract representations in memory to actual pixels on a screen. And the way we get there is WebGL. This is an API that lets us put graphical information into the buffers on that GPU chip and turn that into pixels in a web canvas. And it runs very fast, thankfully. So WebGL is how we actually get these pixels on the screen, not only for 3D objects, rendering them so they are lit properly and shaded properly, but it's how we get our text in there as well. We don't have the ability to hook into the browser's own text engine the way you do sort of thoughtlessly with just a standard web page. So we have to do text rendering on our own, and we use these signed distance function fonts, which let us generate glyphs very fast on the fly. And they're very crisp, so you can scale them up to any size without getting ragged edges or pixelation. And so we actually have to rely on the GPU to do this. We push a special program, a shader, as it's called, onto the GPU with some preliminary information that lets us then be able to tell it, hey, I want to write the words "hello world" onto this texture, and it will do so cleanly.
ThreeJs is something that makes WebGL easier to use. Give a little background to the ThreeJs project.
I'll do the best I can. I'm honestly a bit new to it myself. I've been playing with WebGL for a long time, but I don't necessarily know the history of ThreeJs.
Oh, okay.
But it is, I would say, arguably the best solution out there for talking to WebGL as a JavaScript developer, as a web developer, because not only does it give you really powerful access to the GPU without having to think about different shading types or how to structure a 3D object efficiently on disk and in memory. It handles all that for you. But it also is sort of, I don't want to use this as a dirty word because I know it has negative connotations now, but it's the jQuery of 3D on the web, in the sense that jQuery came to such prominence because it was able to normalize across a lot of different devices and a lot of different APIs. That's what ThreeJS does really well. Is if I deploy it, I know that it's going to work great on Firefox. I know it's going to work great on Chrome. It's going to work great on mobile Safari, and I can rely on it to handle all of those lower level complexities. So that if I say, render a cube with this shading, I know exactly what I'm going to get.
So what's that interface between ThreeJS and WebGL?
Sure. So ThreeJS is creating some in-memory representation of all of these objects, and it constructs what's known as a scene graph. So you can think about this as a 3D DOM tree. You have parent nodes that each have their own children attached to them, so they can all be transformed in 3D space together. And as you walk through this tree, each of these objects in memory is represented by some information that needs to be interpreted by the graphics chip. So some of this will be vertex information that says, this cube has a corner located at, this space in the 3D universe. Some of it will be information that says, the face here points this direction, so this is how you should shade it. There's information there about materials that need to be used, whether you're texturing it to make it look like a brick, or you're applying things on the fly to do crazy effects like reflections. All that information is getting embedded in a way that when ThreeJS runs ideally once every frame, it's pushing updates to the GPU through that WebGL interface. And the GPU is in turn running as fast as it can to push that back out to a canvas. So I can make some tweaks to my 3D scene, and ThreeJS is going to understand what vertices have changed, push some new data to these buffers that exist on the hardware chip, and the GPU is just going to run through its program, and you're going to get new pixels in your canvas tag.
So the stack is React Native code that I guess compiles to or interfaces with ThreeJS code, which is the driver for WebGL code, which is interfacing with WebVR code. Am I getting it right?
Yeah, so we have React code talking to our custom bridge, which is interpreting those React changes in the abstract and turning them into real changes in our in-memory representation.
Right.
We have our own library called OVR UI, which is handling special things like our text rendering that I mentioned. And that's all then talking to ThreeJS to handle the scene layout and the actual rendering. So that goes through to the GPU, and if you're on a phone or a desktop, that's where it ends, is it just goes to a canvas tag. Where WebVR comes in is two key areas. The first is WebVR lets you render a canvas to a VR headset. So I think this is the first real instance of a web browser being able to display to something other than the browser itself. So if you talk to the WebVR APIs, you're actually able to project pixels that the browser has generated directly to the displays on that headset. And then the other place that the WebVR APIs come in is understanding where the user is as a form of input. So WebVR allows you to not only get information on the headset itself, such as how far apart are the eyes, which is important for doing certain calculations when you're doing the rendering, but it also lets you understand where is the user's head located, where are they looking, where are they positioned. And so every time I render a frame in ReactVR, I ask the headset, where is the user right now? And I'm going to use that information to update my point of view when I re-render back to the headset screen. And that full loop of getting the headset's position, updating React, pushing new pixels to the screen is really the core of ReactVR when you're in a headset.
Who do you use for log management? I want to tell you about Scalar, the first purpose-built log management tool on the market. Most tools on the market utilize text indexing search, and this is great for indexing a book, for example. But if you want to search logs at scale, fast, it breaks down. Scalar built their own database from scratch, and the system is fast. Most of the searches take less than a second. In fact, 99% of the queries execute in less than a second. That's why companies like OkCupid and Giphy and Career Builder use Scalar to build their log management systems. You can try it today, free, for 90 days if you go to the promo URL, which is softwareengineeringdaily.com/scalar. SCALYR. That's softwareengineeringdaily.com/scalar. Scalar was built by one of the founders of Writely, which is the company that became Google Docs. And if you know anything about Google Docs history, it was quite transformational when the product came out. This was a consumer-grade UI product that solved many distributed systems problems and had great scalability, which is why it turned into Google Docs. And so the founder of Writely is now turning his focus to log management. And it has the consumer-grade UI. It has the scalability that you would expect from somebody who built Google Docs. And you can use Scalar to monitor key metrics. You can use it to trigger alerts. It's got integration with PagerDuty. And it's really easy to use. It's really lightning fast. And you can get a free 90-day trial by signing up at softwareengineeringdaily.com/SCALYR. softwareengineeringdaily.com/scalar. And I really recommend trying it out. I've heard from multiple companies on the show that they use Scalar, and it's been a real differentiator for them. So check out Scalar, and thanks to Scalar for being a new sponsor of Software Engineering Daily. The focus on the browser is really interesting. I'm trying to get a vision for how this fits into the long term. So is this like, do you personally have a vision for how this works in the long term? Like, does our browser go from a place where we're browsing between web pages to a place where we're browsing between virtual worlds?
Yeah, I think that's actually a realistic ambition and something that may be closer than we realize. I know right now that the WebVR spec team is talking about how to understand navigating from one VR world to the next when you're already in a headset, because no one wants to have to take off their headset, click a link, wait for something to load up, and then put it back on. That's not a great or graceful experience. So once we can sort out these underlying connections and understand how to cleanly get from one distinct web domain being in VR and to a completely different one, you then get the full power of the web, all that interconnectivity. I can only imagine what the equivalent of falling into a wiki hole, where you keep clicking links on Wikipedia until you don't even remember how you got there, and it's 3 days later.
That would be spectacular.
Imagine doing that in VR, where you are able to not only read information on these objects, but view, say, Creative Commons 3D scans of things, or 360 photography sourced from, Flickr or something like that, where all these things are coming together to give you I guess, like a truly immersive encyclopedic experience.
And that sounds so much better than like a world of like the VR app store. Like I would much rather have the VR web app experience than the VR app store, where I've got to like download it, and it's like, okay, I've got this selection of things that are on my phone or my VR device. And no, you should just be able to like navigate there and like get it instantly.
Yeah, that's actually, I think, one thing that I find really romantic about WebVR. So up until its advent, that was how you got VR apps. You would go to some store, you'd wait for it to download. It'd probably be a pretty big application. You'd go and install it, and then you'd spin it up. And so, if you're out and about, and you're traveling, you're not going to necessarily consume new content because you're just probably limited to the apps that are already there. But what the web lets you do is not only distribute these things in a much more democratized manner. If I own a web server, or even if I'm just posting it to, say, a GitHub page or something, I can get my content out there. But it also makes it really easy to evangelize. So if I want to show you something I've created, I can just send you a link. And I don't have to wait for you to go to a store and download it and get into it yourself. And again, with ReactVR, because we have that ability to see it in 2D, even if you're not wearing a headset, I can send you a link. You can take a look. You say, hey, this looks cool. I'm looking at it on my phone right now. When I get home, I'm going to pull this up on my Rift and really get a sense of what's there.
Yeah, okay. So let's talk a little bit more about like building, like the high level. So if I'm a developer, I want to get started in ReactVR. I'm familiar with the React ecosystem. What components do I need to know about? Like, what are the different components that I'm going to start to build my VR experience with?
Sure. So in this hypothetical, if you are an existing React developer, you're our target audience. We want to take everyone who calls himself a web developer or React developer today and empower them to become a VR developer. And so not only are we reusing these concepts of React, that write or learn once, write everywhere thing, we're actually reusing a lot of the React Native systems too. And so when you're laying out an application in 3D space, you have this new dimension to deal with. And things can be a little intimidating at first. So we have two different ways to think about laying out VR applications. The first is going to be most comfortable for traditional 2D UI engineers. And that lets you deal just with 2D panels floating in space. And when you're doing that, you're going to have things that seem a lot familiar to React Native developers. You have views, you're going to have text, you're going to have images. Those are directly hijacked, not only from React Native, but these are becoming really prominent with the React Primitives project. And so with these three classes of 2D elements, you can start to lay out essentially screens that float in space. But with VR, you have the benefit of having infinite screens in an infinite universe. So you're no longer necessarily constrained to whatever fits on the phone at a given point in time. The concept of the fold, being above the fold, is totally gone in VR. So I can have screens surround you everywhere. But that's just half of the VR experience. It's, no one wants to be surrounded by a virtual bank of monitors. To really have something immersive, you need to have 3D elements as well. And this is where React VR moves beyond the existing React Native type setup. And so we're able to have this secondary layout system of 3D objects where you can position stuff anywhere in 3D space around you. These could be 3D models. It could be lighting systems. So if you want to shine a spotlight down on a certain area, set the mood. We have support for things like 360 photos and videos, which are, in my opinion, the best way to create an immersive scene very quickly. You can take these from a panorama with your phone, but now they have a bunch of great 360 cameras out there that can capture an entire scene all around you all at once with just clicking the shutter. So you can take one of these and then drop it in as the base point of your scene. So imagine taking a photo from the center of an auditorium and being able to look around this whole opera hall as you enter this application. And we can support things like that are very unique to 3D too, such as positional audio. So again, going back to that opera hall, I can have the singer with her aria right up there on stage. And as I turn my head, it's going to sound like it's coming from that direction. I remember the first time I did this, I put a little bird sound right over my shoulder just to see how close you could get with this effect and still have it feel real. And it was honestly very immersive.
That's incredible. So talk a little bit more about like how I'm positioning things in 3D space as a developer, and how do I get used to doing that? How do I get used to building like 3D experiences?
Sure. So this is admittedly one of the biggest challenges for a 2D developer moving into 3D space. People who have dealt with 3D before, either as art modelers or game developers, don't really think about these differences quite as much. But in the 2D world, we have two axes that we're concerned about, the X and the Y, and we think about the top left corner of the page, the screen, whatever, as the origin. But in 3D, we add a new dimension to that. We have this Z-axis now, and so we are adding depth to our world. And what gets kind of tricky too is that in a 3D context, and this is just for legacy reasons, the Y-axis is actually reversed from your traditional way of thinking about a page moving downwards. The Y-axis moves up towards the sky in a 3D world. So that could be one of the challenges, getting used to thinking in 3D. But when you are positioning things in 3D, the center of it all, because this really does theoretically extend ad infinitum, but the center of it all is the origin at 0, 0, 0. That's where the user starts out. That's where the camera initially is positioned. And you can think about moving things around you. So if I wanted to have a cube that starts off in front of the user, I would put it down the negative Z-axis. So that depth axis, moving it down away from the camera, and that's going to sort of let it slide between myself and the horizon. There are definitely tools that help you can think about these things. If you spin up a 3D modeling program or a game engine, they'll let you sort of drag and move these things around and get a better sense of 3D space. But it can be a bit confusing for people moving from a 2D realm. And that's why I'm excited for the potential of great developer tools springing up here, the way that you've seen them come up for the web and for the React ecosystem especially. What's interesting about ReactVR is it started as a project within Oculus to allow us to build VR applications faster. But a year prior, a colleague and I actually built at a Facebook hackathon a version of ReactVR just on a whim. And the idea at the time was we wanted to play with custom renderers, and we wanted to see if we could build an environment where we could start live coding the world around us by bringing a React type console into the 3D world. And I think that there's a lot of exciting potential there as VR becomes more prominent and as we add new ways to get into VR, especially something like React that is inherently JavaScript and interpreted, and you can tweak it on the fly. I can only imagine a future where you pop in your headset and you're able to move all these elements around so you get them looking pixel perfect, and then being able to just have that directly connect to your React code and understand where you want to position these objects.
Indeed. Simple example. If I've got a landscape and let's say I want to have a cube that like just sits on top of the landscape, is there anything to help me avoid like placing the cube in space in a way that intersects with the landscape? Because I can imagine like that being problematic. Like, okay, I don't want, I want the cube to float in space, but if I position it in the wrong place, it's going to intersect with the ground, for example. So I'm just like kind of trying to envision what are the frameworks for helping us build things that don't like create, I guess, problematic visual experiences.
Well, at the moment, there's not really anything to assist with that. But that's a similar problem that exists across
game
generations of 3D things. Is unless you have a physics engine or something that's going to say, hey, these two things are intersecting and should not, so I'm going to push at them until they actually are no longer. There's nothing necessarily there that's going to solve this for you automatically. For me personally, the answer is just drawing it on paper first. I get a sense of where I want to put things and their relative size, and then I just use that to understand how I should place these things relative to one another. One thing that's nice is that you do have this hierarchy of transformations, though. So if I'm building a tree out of a 3D object representing the trunk, and I have a bunch of leaves placed around it, I want to be able to place those relative to the tree, but I don't want to have to recompute for every single tree, the absolute position of all those leaves. So one thing you can do is, if these are all contained within a tree component, I only need to worry about positioning that higher level component in my scene. And all of the children are going to transform themselves relatively. This is like relative positioning on the web with the DOM. And so I don't have to worry about every little piece of my scene being absolutely positioned. I can group it into larger chunks, and then those chunks can be distributed.
I'd like to ask some kind of more open-ended questions or just ecosystem questions. When you think back to the platform shift that occurred when people started developing for smartphones, and then how that ecosystem developed, and how probably there were some sacred cows that were slaughtered along the way, and people made some mistakes about, okay, this is how we develop things on smartphones, and that changed over time. What kinds of things do you think we're going to see in VR? Like, what changes in the platform shift? Like, what are the because you hear the classic narrative, okay, when somebody shifts from, or when you shift from the previous paradigm, you take a lot of the baggage of the old paradigm to the new one, and it's only by doing that you realize that it's baggage, and that then you get rid of it. What are the things that are going to change in the platform shift to VR?
Well, it's definitely an open-ended question. I wish I had all the answers to it, because that'd make my job a lot easier. But I think if you think about how smartphones rolled out and applications there occurred, and we try to figure out how that applies to VR, I think there's going to be a lot of similarities. I remember the early mobile era. I wrote apps for Palm OS. One of my first development devices, for being able to be on the go, was an old handheld PC running Windows CE. So I remember how things used to be, and they were just trying to duplicate desktops. And they tried to clone that paradigm almost directly. And then the real shift, I think everyone will agree, happened with the iPhone, where it made a lot of changes and a lot of sacrifices. But one of the tricks that it pulled, that I think you really have to give it credit for, is that it was able to bootstrap its platform with the web. And so there weren't a lot of apps out there for the iPhone at launch. And so to get around that, to keep people engaged with the device, they found a way to take the desktop web and make it look nice on mobile in a way that you wanted to consume it. And so you could still sit there hours a day browsing the web in a way that felt natural. And so I think that for VR, we may very well have a similar trick, which is you take applications like we're building with ReactVR that people may just be consuming it on a mobile phone, looking at it through a magic window, or clicking and panning around this 3D world through sort of a less immersive experience. But as we start to deploy these, we can use this to get more VR content out there and let people explore. It's going to take a lot of time for people to learn how to develop for VR. And I think one of the biggest challenges is interaction paradigms. I'm going to be frank. In my opinion, we haven't found the ideal VR interaction paradigm yet. That's going to take a lot of experimentation. But a lot of the things that we take for granted on mobile too it took maybe 10, 20 years for people to understand that that's how they wanted to interface with a handheld computing device. And then once you find these things that really click with users, one person invents it and everyone else just steals it, because that's art, right? So one of my personal hopes for ReactVR and the VR ecosystem as a whole is that by taking any web developer and making them a VR developer, and letting more people not only deploy applications to a growing body of users quickly, but also be able to tighten that loop of going from design to implementation to testing, and being able to rapidly iterate on that the way the web is famous for. I'm really hoping that we'll be able to find these optimized interaction paradigms a lot faster, and maybe take this from the mobile phone timeline, where we were looking at 10 plus years to go from Win phones to the iPhone, and maybe get closer to 2-3 years to find these ideal interfaces that people then take for granted and distribute across every VR type device.
How much time do you personally spend in VR?
Not as much as I'd like, I'll tell you that.
Really?
I'd say most of my time right now is spent gaming in VR, or most of my time in VR is spent gaming. But that's probably only maybe an hour or so a week. By the end of this year, I actually have a personal goal of moving a lot of my productivity into VR,
awesome.
Where possible. So I've always been a denizen of the browser. I'm a web development nerd, always have been, and I try to use and abuse the browser as much as I can. And so over time, I've moved a lot of my productivity tools into the browser, either directly through web apps or through extensions, being able to have some connection to the underlying system. So like when I pop open my new tab on Chrome right now, I have my task management, time management things. I have a terminal emulator that I built. So I can do a lot just from within my browser, and I enjoy doing that. Mm-hmm. So I want to take the same paradigm of, at least for me, being able to get a lot done in what most people think of as more of a restricted environment. And I want to be able to take that over to VR. My dream is that, a year from now, I'm going to be able to get on an airplane, pop on a headset, pull out a Bluetooth keyboard, and just be able to code the whole flight with a whole bank of monitors and not think about being crammed into economy class.
It's so great to hear you say that, because that is what I would love to do. Hell, it's what I'd love to do, like sitting in my chair at home, frankly. But I'm a little scared of it. Like I'm just scared of we don't know, the health risks. Is this going to hurt my eyes long term? And I'm not saying this at all in like, how dare you explore this space? There's so much health risk. Like I'm really bullish on it, and I'm glad people like you are exploring it. And at the same time, I'm just like, how quickly can I adopt this stuff? And I think that it sounds like for you, that's kind of an open question as well.
Yeah, I'm going to hedge too. There's a lot of things that I know I'm not going to be able to do in VR soon, or frankly want to do. So for instance, I do a lot of reading. Whether it's on a tablet, whether it's on a laptop, I consume a lot of material. And I don't imagine that's going to be something I want to do in VR anytime soon, just because the resolutions aren't at the point where looking at something in VR is going to be a better experience than looking at a tablet screen or a printed page on a book. But arguably, you still have to really use your imagination to think of a place where, reading something in a virtual world is going to be more compelling than reading a book. I mean, if I can have a book come to life with scenery around me, sure, that's having articles that have 360 photography, I'm looking forward to that day. But if I'm just consuming a lot of tech knowledge or something like that, I'm still going to want to read it essentially on a printed page. So I'm going to hedge there and say, not everything's going to move quite so quickly. But for the things that I think are within reach, especially, if I can get a dumb Unix terminal in there, we've been adapting software to these things for so long that even with a smaller screen, fewer resources, I can still get a lot done all from within an 80 by 25 terminal.
It surprises me that you say that about the reading stuff, because I would love to. I think most of my reading experiences would be augmented by VR, because I do so much context switching while I'm reading an article. Like I'm reading something and then I'm like, oh, got to share this, this thing makes me want to go read this other thing. I'm going to go context switch, and maybe I'll pop that stack eventually and come back to this article, or maybe I'll just go off on a Wikipedia tunnel. But I can imagine just the immersiveness of VR making reading more interesting, even if it's just simply like porting the current experience where I have a limited frame of view to a 360 frame of view. Like, frankly, the only thing that keeps me from wanting to do that is, like you said, like the resolution or perhaps the health risks.
I think one of the things there too is content producers, media producers are going to be dealing with the same challenges that application developers are dealing with. So whereas on one hand you have app developers, game developers trying to understand how to translate what they know into VR, the media industry is probably going to undergo a similar challenge that it did when it moved from print to web, which is as the medium changes, as you can do more with that. So they were able to embed things like videos or interactions, things you couldn't do with a magazine before. They're going to then have to figure that out for the third dimension, understand, what does it mean to augment your article with, say, 360 photography or interactive stuff. I think now about some of the digital productions that have come out of the New York Times, where you have this really immersive media experience where you're reading an article and they provide all sorts of contextual photography and videos and audio as you're going through there. And they've created really, best-in-class websites, to contain this stuff. So I think that if you sort of imagine carrying that over to the third dimension, all the things that allows, there's definitely an exciting potential for print media to exist in VR, and I'm really excited for that. You brought up the context switching. A lot of the stuff that I do on the side that isn't programming related is studying ancient languages. I have archaeology background, and there's a lot that's in there where you need to have, say, 3-4 books open at a time, being able to inspect a lot of different things. And I can only imagine it's going to become a lot more productive if I can start to have a lot of that information existing around me in sort of an infinite space.
Yeah. Is anyone working on React AR?
So, not explicitly, but I think that's because ReactVR is React AR.
Oh, okay.
So I mentioned earlier that some of the people working on this WebVR spec are also trying to understand how to adapt it to React AR. One of the great things about developing it was when it first started, I think Mozilla was really leading the charge, and they were looking at Oculus Rift and everything. But when Microsoft got involved and they were, adding it as a browser vendor for Edge, they said, hey, whatever we do here, we need to make sure we also support these mixed reality headsets. Like, right now they are deploying, I think later this month, a bunch of headsets that have pass-through cameras that let you see windows in a 3D world. And so that's sort of the first stage to AR. And they made sure that the spec adapted to that. And so recently at Google's last developer conference, I think it was at I/O, they previewed some of this stuff. They previewed a build of Chromium that uses the AR cameras on Tango devices. That's Google's hardware platform for augmented reality. And it was able to deploy augmented reality web apps. And so I saw this video and I said, hey, that's really cool. And I went home, downloaded this experimental Chromium build, did some really hacky things to wire it up to ReactVR. But a lot of the things that should have seemed weird actually were quite graceful because it's using the exact same WebVR system to determine where the camera is positioned relative to the world. It's doing a lot of things. I just had to wire up some extra WebGL extensions to allow that pass-through camera. But I was able to get ReactVR running in an AR context, and I was able to position objects on my table. So I could take these 3D scenes, and if you imagine just getting rid of the 360 photos and the 360 videos that surround you, and just letting that be the existing world, with AR, it's no longer a black, empty space, a vacuum. You're just taking the camera view from the back of the phone and putting it on there. And so you can start to take these ReactVR applications and deploy them to augmented reality with feasibly no real change to your React code. Yeah, I'd say ReactVR is going to be React AR. We're just waiting for the APIs to catch up.
And when you look at something like ARKit, I think if React is going to be able to, like React Native, is that going to be compatible with or be able to build something on top of ARKit?
I honestly couldn't say, but that's one of the beauties of open source software and also being able to inspect it is I wouldn't be surprised if someone else went out there and built a target that did exactly that. Yeah.
Okay. Well, I know we're nearing the end of our time. I just want to ask you, because I like to ask anybody that's engaged in VR heavily the simulation question. Like, to what degree do you believe we're living in a simulation, or to what degree do you believe that we can create a simulation that is as immersive and convincing as the reality that we live in?
Well, I'll just say this. When I was in high school, I got very involved in agent-based modeling. So sort of like Conway's Game of Life, where every little piece of the board has its own set of rules that it follows, but taking that to a huge scale. So I was building out simulations of urban environments to understand things like how diseases spread. And as I did that, I started to develop this sort of sense of, if I were an all-powerful entity, and had all the infinite time and resources in the world, how would I build things? And would I establish a small set of rules and just see what grows from that? Because when you do play with these simulations, it's fascinating to see how a very small set of initial rules can lead to very broad consequences in these virtual worlds you're building. So I've always found the concept fascinating, and frankly, I think if I had the resources and the power, I'd be guilty of probably building some sort of simulation like that.
Yeah, well, you think about the fundamentals of physics. I mean, maybe those are those rules that you're talking about. I mean, you could just say map out the fundamental laws of physics, and then click go, run, and that's somebody's running that simulation somewhere. I think that agent-based simulation stuff is actually what got Vitalik interested in Ethereum. So that tends to be a fertile ground for computing minds, it appears.
Yeah, it's interesting to see how it leads to new concepts of distributed computing.
Yeah. Okay, Andrew. Well, I'll let you get back to work. Thank you so much for making the time. I know you're a busy guy, and it's a real treat to be able to get a firsthand explanation of what's going on in ReactVR.
Well, thanks for having me on the show. It's a pleasure to share it all.
If you are building a product for software engineers or DevOps engineers, consider advertising on Software Engineering Daily. There are 24,000 engineers that listen to Software Engineering Daily on a daily basis. And if you've got a product or a service that you would like to get into the ears of those developers, we'd love to have you as a sponsor. You can send me an email, jeff@softwareengineeringdaily.com, and I'd be happy to tell you more about our sponsorship options and some of the success stories. We've got many repeat sponsors like Hired.com, Datadog, MongoDB, Amazon Web Services. These are big companies that know how to market to developers, and they have their advertisements run on Software Engineering Daily. So send me an email, jeff@softwareengineeringdaily.com, or if you work at a company that you think should sponsor Software Engineering Daily, tell your manager and have them send me an email. Thanks again to listening to the show and all the listeners who support the show by checking out the advertisements. You are much appreciated. Now let's get on with this episode.
Wow.